You heard in previous talks some discussion about Moon, Mars, and beyond. There are two pieces of that I'd like to take on here. One is the Mars piece, and deal with that for a few minutes. And the other is, and beyond. I think we should be calling it Moon in between Mars and beyond. And that'll become clear in a little bit as to why I say that. Today, we are in no position, that is zero, in terms of our ability to take humans to Mars. There are two major issues which have not been solved. One is entry, descent, and landing of large payloads on Mars. The systems do not exist, and nobody's quite sure how to design those to land 20 to 40-ton payloads on Mars with that thin atmosphere. Ultra brute force might do it, yet there's a major problem of logistics in getting to the surface of Mars with large, very large payloads. Second is what we've been finding on Mars through the robotic exploration. If any of you have been following the Mera rovers, earlier missions, the Phoenix missions, and back at Viking. Viking found no signs at their level of detectability at parts per million of carbon. Yeah, carbon's coming in from meteorites, if nothing else. Where the hell did the carbon go? And that, of course, is a clue to life. No carbon, no life, as far as we know. Apparently, it gets totally destroyed by the highly oxidizing environment of the surface material on Mars. Every mission has seen that. It is full of highly oxidized stuff, perchlorates. Now, how would you all like to suck in a mouthful of perchlorate? I hope your lungs are lined. So there is a major issue involving the dust particles on the Martian surface. Much as on the Moon, the dust is a problem there, not for the same reason, but it's the same basic issue. We've got to understand what that material really is, and can one live with it rather than die with it. It's vigorous material. We need to understand that. So there are some challenges to the Mars exploration. Doesn't mean that they're killers now. We usually find ways to solve these, but that's one that's got to be taken on until we understand how to deal with those two problems and solve them. The Mars is an interesting target object out there for the latter part of this next 50 years. Meeting the challenges for Mars. Do that before I come back to the in-between part. The support in Congress is maybe amazingly at times rather good. We don't find too much opposition, other than maybe Barney Frank, who put a constraint on NASA last year not to do any studies that relate strictly to human exploration of Mars. Well, usually we can work around a lot of that, but it has put a crimp in things. So we've got work to do up on the Hill to open up at least the study possibility, not constrain ourselves. When we constrain ourselves, we are not yet doing the right job of feedback from what is required to get on Mars, work there, live there, and feed those back into the lunar program and in-between destinations. We've got a very limited focus right now on the lunar program without adequate feedback from what we'll eventually need for Mars. Heavy lift capability is obviously one thing that will be needed and is underway, will be needed for the lunar program with the Ares 5. We need unbelievably reliable space transportation and living systems. If you watch the space station today and what it takes to keep it going, and granted it wasn't designed as a Mars mission habitat, yet it's indicative of some of the problems. If you took the space station and said, send it to Mars for a 3-year mission, would you go? Maybe some of you would, and I'll sign you up. But system reliability is a major issue that must be worked and is not as easy as it sounds. Repairability, being able to survive the kinds of problems that we saw in every human spaceflight program is going to take a new level of thinking and integration into repair capability and how we best use a partnership between astronauts in space and ground capability. But you sure have to have a lot of capability that you're taking along with you on these kinds of missions.